Yes, hello everyone. This is a group of two, Simon Onen and Mugabi Samuel, presenting how we are going to use machine learning to solve the bicycle imbalance in bicycle share systems. So, bicycle share systems have become very popular in recent times, but they're not new. They're not a new system. They started way back, and the oldest systems were found in Europe, mainly Netherlands. That's where bicycle share systems started from. They help urban cities solve very many problems that are caused by the model of a person sitting in a car. That causes traffic jam, it causes high carbon emission, and very many other health-related issues. On the contrary, someone cycling or walking, they reduce carbon emissions by about 10%. That's what research says. Now, allow me introduce bicycle share systems to those who may not be knowing it. It is composed of mainly three components: a docking station, bicycles, and a hire platform or renting platform. This renting platform can be a website, an application, or they can be swap cards, depending on the owners of the bicycle share system. Now, someone hires a bike from this docking station, as you can see the docking station there, moves from point A to point B. Another person comes, moves from point A to point B. And at peak time, you'll find that people are moving from point A to point B, causing an overflow at point B and an underflow at point A. And yet users still want bikes at point A. Now, this is where our machine learning model is going to come in from. It is going to help us predict these imbalances in the bicycle share system and hence help solve the imbalance problem in bicycle share systems. For AI accountability, we divided it into 4 dimensions. Governance structure. The governance structure, it is Mugabi Samuel and Onen Simon that are solely responsible for anything that might arise in this machine learning model. Any issue that comes up, we are solely responsible. The data, we are going to use a data set from Blue Bikes found in Boston. We talked to them, their data support team, formally through a series of emails, and they responded to us. They gave us a go-ahead to use their data so as to for study purposes. They also shared with us the data privacy license that we should follow so as not to go against it. Performance and goals, we're going to use F1 score, recall, and so on and so forth. Then for the monitoring, we are closely going to monitor the machine learning model so as it does not develop biases or come up with functions that cause ethical biases that are not good for the society. The significance of our project is that it's going to help predict where the imbalances are going to be. And then it will, in this prediction, it will help mainly 2 people, the bike sharing system administrators, so that they can transfer bikes to where the demand will be and preload the high demand areas with more bikes. And also it will help the platform users so that they don't come to a docking station and there are no bikes at time of need. Now, at this point, allow my colleague take over from here. Yes, Simon.
Yes, thank you, Samuel. Looking at our project scope for this machine learning project, we broke it down into 4 phases that imitate how a machine learning model is supposed to be built. The first one is what so far we had started and we have looked at the data identification and preparation, where our data set was identified and we went through all the formal criteria to achieve permission to use this data set. And earlier on, Blue Bikes accepted and gave us an approval to use this data set. as long as we follow their data and licensing agreements. And then we propose to move on to the exploited data analysis, where we are going to conduct it through using the pandas library, which provides sophisticated methods for usage. And then also this analysis will be done with machine learning seaborne library, which is developed on top of matplotlib, such that as we are doing the analysis, we need to understand the connections between the different features. As far as we look at the features, we have around 18 features on the data sets, with each data set corresponding to over 2 million data points. And then for our model creation and evaluation, what we are going to do here is, during our model selection, we are going to pick the variables using intuition, where we first say if we're looking at the number of trips made per year, how does it correspond to the docking station the bike was picked? With the bike, we're looking at the feature of the bike ID, and then also the start time of the trip to the end time, and among others. Then our models will be developed and evaluated in order to find out their accuracy, because a model has to be accurate before it is deployed. And then the evaluation criteria we are going to use, as someone said earlier, we are going to first test all the models on our data set. We are not just going to emphasize that this is a classification and then move forward. We are first going to try out all the machine learning models. And one of the evaluation techniques we are going to use are confusion matrix, the area under the curve, and among others, the mean absolute error. All those model matrices will be used to evaluate our models. And then the final part for model optimization techniques. Now, as we understand, these models are just fed with data and we expect an output. But at a certain point when we are building this model, what we want to do is to ensure that it works better by making accurate predictions. So what are we doing about this? We are going to be using hyperparameters to make them even better. And since the data set we have provided was for 2 years, 2019 and 2020, after the approval given to us by Blue Bikes, they gave us a provision that we can actually refer to their open data, which is for 2020, 2021. So if we built our model and trained it with the previous data set, we can optimize it using the data set of 2020, 2021. Samuel, can we move on? Then the hypothesis. Then the hypothesis here, we are looking at how we want to draw conclusions from the different machine learning models we are going to build. So this is we are looking at here assumptions we are going to make. For example, regarding the idea that there is no anomalies or beliefs in some of the assumptions. And then also in contracts, we are also going to look at the null hypothesis to find out what is observed that is in effect actually real based on the data. Then after the hypothesis, if you can move on to the data description. So about our data description, what we are looking at here is what kind of data and then the criteria we went through. As I explained earlier, we went formally. We first identified the data set on Kaggle. Then we reached out to the actual authors of the data set. Then after several approvals back and forth with the data support team from Blue Bikes, were given permission to use the data sets. These data sets are for 3 years, and each year has at least 2 million records. And there are, for 2019, we have 18 features, and then for 2019, we have 17 features. And then for 2021 is what they are yet to use. Then when we move on to the proposed methodology, when you look at all these AI models built, it's like a black box that is fed with functions, and then we expect an output. But at the end of the day, for us, we propose that we are going to use the LIME technique, which stands for the local interpretable model agnostic explanation. Now, this looks at, first of all, explainability and then the transparency. So under explainability, what are we looking at? We want to find out how our model will be functioning in a particular manner. And also under transparency, we want to find out how is it simpler to comprehend how it operates. So how can you explain how a model works? So we are choosing this line technique because of that. And then the other thing additional on top of that, since for it, when it is choosing an algorithm, it doesn't look at the entire model. It looks in the local context, and that's why it is called the local interpretable model. It looks at the instances described around it while modifying the features. Then, if we could move on to the next slide, we'd also want to acknowledge Ariel Kavi, who helped us and is the one from the data support team that enabled us to get this data from City Bikes. That summarizes the presentation about our concept, and we look forward to developing this machine learning model based on the project scope shared.